Welcome back to Bilinear Algebra 2, and this is the last session of our study. We started the study, and the last session is talking about the bilinear form of the matrix. The previous ones that we have treated is treated the quadratic form of the matrix, where you have a variable x, and this bilinear is a form of a function variable xi and yj of the type b of x comma y equals to the summation from I to n of x, then summation from j to n of y, which is given as x transpose ay, where your a is the coefficient of the functions. A is given as aij, is an n by n matrix, n by n matrix, and xi and yj is a real number. This is called a real binomial form. This equation is called a real binomial form. So we want to look at the matrix representation. A binomial form can be expressed in a matrix form as b of x comma y, which is equivalent to x transpose a y, where your x is a column vector. So by the time you transpose it, you have it as x1, x2, x3 and so on to xn, and your y, to transpose your y, we have y1, y2 up to yn, and a, as I've said, is the coefficient of the matrix. The matrix A is called the matrix of the form. So whatever you get from the matrix is the form of the binomial. Is the binomial things that we are talking about. That is, the matrix A is called the matrix of the form, of the binomial form. So we look at the rank of the binomial form. When we are talking of rank, we test the rank of that binomial form through the matrix. If the xi and yj are independent variables, then the rank of the binomial form is defined as the rank of its coefficient matrix A. The rank of that binomial form is defined as the rank of its coefficient matrix A. That is, when you are given equations of binomial form, you get your matrix A from the equations given to you. So the rank of that matrix, the rank of the matrix is the same as the rank of the binomial form. Then as I explained earlier on in our previous class, we talk about the n by n matrix, which contain all the coefficients of binomial form, is called the matrix form. And there are two things we look at. If xi and yj are independent variables, the rank of A is called the rank of the form. Then, if the matrix of the form is symmetric, the form itself is also called a symmetric. So, it's what you get from the matrix that will determine the binomial form given to you. So, if A is a symmetric matrix, that is, you have your aij equals your aj high. You know what a symmetric matrix is. When you transpose, you still have it back. Then the binomial form is called a symmetric linear form. Symmetric bilinear form are closely related to a quadratic form. They are related to quadratic form. So we want to solve some examples for better understandings of the topic. Example 1. Reduce the binomial from this. That is, b of x comma y is given as 2x1 y1 plus 3x1 y2 plus 2x2 plus x2 y1 plus 4x2 y2 to its matrix representation and find its rank. This is equations given to you. This is an equation given to you, a binomial form. So from this equation now, we find our matrix representation. That is, we bring out our matrix from this equation, then find the rank of that matrix. So the rank of the matrix is the same as the rank of the binomial form. So we want to establish that. So from the equations given to us, we can get our matrix A, which is A, B, then B, C, our matrix A. So from what we have here, the coefficient now, our A1 is given as 2. Then our A12 is given as 3. Then our A21 is given as 1. Then A22 is given as 4. As you can see from the equation, A11 is the coefficient of x1, y1. Then A12 is the coefficient of x1, y2, that is row 1, column 2. Then row 2, column 1, the coefficient is 1, when you have your x2, y2. Then A22 is when you have your x1, the coefficient of x2, y2. And we have gotten our matrix A to be 2, 3, 1, and 4. Just we want to establish now the definition. By definitions of a bilinear, we have b of x comma y equals to x transpose y, ay. And what is our x? Our x, you can see from the questions, you have x1, x2, so it's 2 by 2 matrix. So you have your x1, x2, and your y is y1, y2. You can see from the equations. So the next one is for us to transpose our x. You transpose it is a column vector. So when you transpose this, you have it as a row. So you have your x1, x2. Then bringing out your matrix A, which is 2, 3, 1, 4. Then multiply by your y, which is a column vector, y1, y2. So your matrix multiplications of matrix will start to multiply. So take care of your A, use your A to multiply your y. So the row 1 will multiply that column vector y. So you will have a 2y1 plus 3y2. Then for the second row, you will have y1 plus 4y2. So having done that, then you use what you have there. You use your x transpose to multiply it. So you will have your equations. To find the rank of that matrix, you find the determinant of that matrix. If the determinant is not equal to 0, like this one now, you have 2 by 2 matrix. The only thing you can do is just to find the determinant, and the determinant is not equal to 0. So the rank of that matrix is 2, because it's 2 by 2 matrix. That is, you have it's not 0. The row is not 0. So hence the binomial form is of rank 2. Let's look at the second example. Show that the binomial form associated with the symmetric matrix is symmetric. we are to show that the binomial form associated with a symmetric matrix is symmetric. We want to establish that statement. And our A is given as A, comma B, then B, comma C, which is symmetric. So we want to show that the binomial form associated with a symmetric matrix is symmetric. Remember the definitions of a symmetric matrix. So let A be A, given a matrix AB, then B, C. This is a symmetric matrix. You can see this matrix, if you transpose it, you will still have a matrix A back. So that is the meaning of symmetric, which means it's a symmetric since your A12 is equals to A21. You can see row 1, column 2, we have it as B. And your row 2, column 1 is also B. So they are the same. So far your A21 is equivalent to A12 is equivalent to A21. So it's a symmetric matrix. The binomial and the bilinear form is given as B of x, comma y equals to x transpose AY. That is, you transpose your x, which is x1, x2, multiplied by a matrix A, which is AB and BC, then multiplied by your y1, y2. The first thing we do, we multiply our matrix A by y. So we have AY1 plus BY2. Then the second row, we have BY1 plus CY2. So the next one is to multiply your X transpose by the product of the two, the product of AY. So when you do that, when you open the bracket, you will have your X1 of AY1 plus BY2, then plus X2 of BY1 plus CY2. So when you open up the bracket, you will have the equation as AX1 Y1 plus BX1 Y2 plus BX2 Y1 plus CX2 Y2. So you have opened up, you can see the bilinear equations now given to you. So when you have an equation like this, when you are given an equation like this, you should be able to form your matrix A from it. So this is the product, the result that with a symmetric matrix, we have a binomial form with a symmetric matrix. So the matrix is symmetric, then the bilinear form is also a symmetric one. Now we want to consider, we have look at B of x, comma y. So you want to find it in another way around, where you have your B of y, comma x, whether they equal, whether the result, the product will be equals to each other, because we are talking about a symmetric form. So we have B y, comma x. So this time around, we are finding y transpose multiplied by ax. You know your y is a column vector, so when you transpose it, you have it as a row. So you have y1, y2, multiplied by your matrix A, which is A, B, B, C, then multiplied by the column vector x, which is x1, x2. So when you multiply your A by x, you get the product, then you use your y to multiply the result. So you will have a y1 x1 plus by1 x2 plus by2 x1 plus cy2 x2. So you can see that the result here with the previous one, they are the same. Since multiplication is commutative in real number, this equals to, that is, our b of x comma y is the same thing as b of y comma x, because multiplication is commutative. Hence, the bilinear form is symmetric. We're able to establish that they are symmetric, because what you get from your byx is the same thing as your y bxy. So let's look at another example. From the previous material given to you, there is a question there that you have to reduce the binomial form. The binomial form, to reduce the binomial form is given the matrix. So find the binomial form associated with, okay, example 3 now. Find the binomial form associated with the matrix this. Our A is given as 1, 2, 3. Then our B, the matrix is 1, 2, 3, then 0, 4, 5. The first thing is to find the rank, to determine the rank of this matrix. We want to determine the rank of this matrix. The binomial form is given as x1, x2, because we are having two rows for 3 columns, 2 by 3 matrix. So we have x1, x2. Then we have the coefficient as 1, 2, 3. Then it's 0, 4, 5. Then our y, which is y1, y2, and y3. So what we do now is to multiply. You open your A, use your A to multiply your y. You will have the product as y1 plus 2y2 plus 3y3. Then you will have 4y2 plus 5y3. So use your x1, x2 to multiply the product. So you will have it as x1 of y1 plus 2y2 plus 3y3 plus 2x of 4y2 plus 5y3. The rank of A is computed as follows. The rank, you have the row 1, you have the row 2. So these two rows are linearly independent. Thus, rank of A is 2. Hence, the bilinear form has rank 2. Has rank 2. I think you can still recall from your 203 how to find the rank of a matrix when you use your row reduced echelon. So the non-zero, the entries, the number of non-zeros line that you have here is the rank of the matrix. So this one, the bilinear form has rank 2. So the exercise given to you in your materials, reduce the bilinear form this. You have your 1, 1, 1, 2, then 2, 2, 3, 3, 3, 4. You have it as S transpose multiplied by A, then multiplied by Y. So when you transpose your x, you can see from the matrix A, we have 3 rows. We have 3 rows, which is telling you that it's 3 by 4 matrix, 3 rows and 4 columns. So the row here is our x, and we have row 1, row 2, row 3. So we have x1, x2, x3. So when you transpose your x from column to a row, so you have it, then you have your y, because we are having 4 columns. So we have y1, y2, y3, y4. So it should be y2, not y1 there. So where your A is given as 1, 2, 1, 1, 1, 2, then 2, 2, 3, 3, 3, 3, 4. The first thing to do is to expand expansions of the bilinear form. You want to expand the bilinear, which is you write it in a standard form, that is S transpose AY. So you transpose your A. So the next thing for you now is to open up the bracket. You multiply out. Multiply your A by Y. Multiply your A by Y. When you do that, the product, now use your X to multiply the products that you get from it. So you have it as B of S comma Y to be equals to X1 of Y1, Y2, y1 plus y2 plus y3 plus y plus 2y4, then plus your x2 of 2y1 plus 2y2 plus 2y3 plus 3y4 plus x3 of 3y1 plus 3y2 plus 3y3 plus 4y4. So the next thing to do for us now, we have gotten our equations now. From the matrix given to us, we have gotten the bilinear form of the equations now, which is this. This is your bxy. So we want to reduce the bilinear form now. We want to reduce it. We want to reduce the bilinear form. The first thing for us to do is to find the rank of that matrix. How do you do that? You have know your matrix, which is A, and is given as 1, 1, 1, 2, 2, 2, 2, 3, then 3, 3, 3, 4. So you apply your row reduced echelon form. Now to do that, our new row 2 will be equals to, we want to make the second row here to be 0, the third one, the column 1, on column 1, you reduce the second row to 0, reduce the third row to 0, and like that. So when you do that, you will have your new row 2 to be row 2 minus 2 row 1, because you have 2 in your row 2. So in order to make row 2 to be 0, you have to subtract from row 1. So you have to multiply your row 1 by 2 and subtract. So you will have 0 there, which you have gotten here. Then for your row 3, you want to make it to be 0 also. You multiply the new row 3 now will have the row 3, the whole row 3 minus 3 multiplied by the row 1 to make that row 3 to be 0. So when you do that, you have your result as 1, 1, 1, 2, 0, 0, 0, minus 1, 0, 0, 0, minus 2. So the next thing is to get your new row 3 again. So the new row 3 will be given as row 3 minus 2 multiplied by row 2. 2 multiplied by row 2. So when you do that, you see that we have reduced the matrix. We have reduced it to 1, 1, 1, 2, 0, 0, 0 minus 1. Then the last row, they are all equals to 0. So there are two non-zero rows remaining after row reduction. After our row reduction now, we have two non-zero rows that are remaining. So therefore, the rank of that matrix is 2. The rank of the matrix is 2 because we were able to reduce it to two lines, to two row, not zero, two not zero row remaining after row reduction. So the rank of the matrix is 2. So the rank of matrix A is 2. This means that the bilinear form can be reduced to involve only two independent cross terms. It can be reduced to only two independent cross terms.